Started. So good afternoon. I'm going to introduce to you Rohit. He's on principal engineer on the Ansible networking team. He's going to be talking to you today about network backups and restore with Ansible. So over to you, Rohit.
Yeah, thank you. Good afternoon, everyone. And again, thanks for joining the session. Again, my name is Rohit Thakur. I'm a principal software engineer at Red Hat. And today I will be talking about a particular use case that is like network backup and restore with Ansible. And I will be covering how do we build or write a solution which is idempotent in nature, platform neutral, and then we'll try to go through some features which are more about adding the severity, diff severity scoring, and then probably adding some hashing in terms of ensuring that there is backup integrity. So let's see what we have in our agenda. Apart from some brief introduction about the whole use case, we'll talk about why network backups are hard, and then I will show you solution overview. There will be architecture overview as well, which will be more about what kind of collections we are using, modules, plugins, and how we are actually stitching everything together. Then we will talk about these core features, which covers idempotency in backup operations, then vendor neutral design, where you can automate backup and restore irrespective of the platforms which are supported for now. Then diff severity scoring, and that includes two methods here. One would be rule-based parsers we can write, and the other one is more on the side, which is more like a POC right now. We are exploring that is based on certain machine learning models. Then there is backup verification. So when it comes to backup and restore operations, we want to make sure that everything is verified. If it comes to restoring certain snapshots, we want to make sure that there is a mechanism to verify the integrity of those backup files. Then there is SCM integration. In this case, in this example, I will be using GitHub. So we'll go through that, and I hope there will be some time for Q&A as well, and then we'll see what will be the key takeaways out of it. Okay, so here is what we will cover today. One is we'll discuss what are the challenges with traditional backup approaches we have. Then I'll walk you through the solution architecture we are proposing here. And then some key features which I just mentioned about around the idempotency, diff severity scorings. Based on that, you can trigger certain workflows as well. Then there is the verification for the backup integrity, and we are using SHA-256 algorithm for it. Then I'll try to give you a demo. I have it recorded because there are at least 6 different sections of the demo. So I thought it's better to record those demos than to deal with the demo god here. So okay, so let's talk about the problem here, why network backups are hard. I mean, some of you might not feel like those are hard, but yeah, these are the things or the feedback we have got so far from the customers or from the community as well. So challenge one is vendor lock-in. Every vendor is basically have their different method of backup operations. And when it comes to, let's say, Cisco IOS appliance, the command might be different compared to Juniper Juno's appliance as well. And then again, the default path where those backup files are getting pushed or for the restore operation are definitely going to be different. Even under Cisco, for XR and XOS and iOS, there is that difference. So, and again, each of these platforms, they come up with their own quirks as well. Some of you, or even I used to do it when I was developing some networking nodes, specifically in the 4G, we used to have different backup scripts or mechanism to deal with the different kind of platforms. Challenge number 2 would be false positives. Okay, so for these backups, there will be metadata. And for example, there will be some timestamps as well, comments as well, which most of the time are going to create noise in the version control system. So we want to also have an option where we can actually learn about that metadata, and instead of pushing backup every time, if the difference is not just in the metadata, we only want to push the backup, otherwise we can simply ignore that. Okay, so again, in terms of this particular SCM, which is GitHub, this might lead to commits or PRs with just the difference of having the metadata. So next, challenge number 3 would be no change prioritization. So most of the time, all of the changes are going to look same. You changing a description in an interface is going to be treated equally compared to someone simply crashing your BGP. I mean, the potential change which could cause that crash. So there is no way to know if a change is critical or low risk, right? So you have to be very careful around those changes. Challenge number 4 is backup integrity. Again, if we have pushed certain backup files as a, like I would say, a snapshot which is safe to restore later on, and somehow by mistake that gets corrupted, or someone changed that backup file configuration, so that might lead to some discrepancies over there as well. So let's talk about solution overview here, and I'm going to mention certain core principles. One is idempotent, only backup when actual configuration changes occur. We talked about what we want to ignore in terms of some metadata there. Then comes the vendor neutral. I want to have one playbook which can take care of different platform as well. So instead of providing platform specific information in that playbook, it should take care of all that stuff under the hood. Again, vendor neutral is getting repeated here, so we can ignore that one. Then comes some sort of intelligence which needs to be there. It could be we trying to score the kind of differences we are seeing in terms of the configuration. We talked about it. It could be interface related changes where we are saying that okay, maybe it is not that important, and we can simply go ahead with pushing those backup files. Then secure, where we are ensuring the backup integrity. We will be using network backup collection, which is there, and again a bunch of other collections are going to be stitched together. We will go through that architecture as well. So, and again we are going to integrate everything with the GitHub here. So this is what high level view in terms of like understanding the architecture over here. So we have a backup collection, network backup. I'll be sharing the links at the end of the slide as well. And that collection basically has two roles. One is network backup and the other one is restore. So with network backup, a lot of things are happening underneath. One is like it is ensuring that it is platform neutral in terms of reading everything out of the inventory and then deciding okay, what platform supports what kind of connection or what kind of commands needs to be run on those platforms. Then again to have that logic of ensuring that we are not pushing backup when it's just a metadata change, we need to normalize the config we are comparing. So it could be a running config you are trying to retrieve and then push as a backup snapshot or the existing one. So that will be there, which will be getting covered with that particular collection, and then there is a restore role as well. So that collection is capable of talking to GitHub because underneath it uses another collection called ansible.scn, which has that all the support where you can publish something on the GitHub and even retrieve it. So that is like on the other side, we can see that restore role is there, and in between we have a data store. You can have your local data store as well, where you can push everything and retrieve the backed up files from there. Okay, so this display what kind of modules we are trying to use here or the collection. So we have network backup where we have these roles we will be using. We have Ansible netcommon where we have written modules CLI backup and CLI restore, which are, I think, so those are the modules which actually implement all that logic of getting connected to the device and ensuring that we are doing SCP or SFTP to the device, making sure that config file is sent to the device, and later on we can trigger the restore as well whenever it is required. Again, Ansible SCM getting used in there, specifically git publish and git retrieve are those two modules which we are using in this particular solution. And then on the other side you see we have different platforms which this collection is able to take care of. So you're going to write one playbook and that's going to fetch the the running configuration, create a backup file, and push that onto the GitHub. Okay, so key feature at glance, we will be talking about it. So let's just go through it, and then we'll try to explore each of these separately. One is idempotent backup, vendor neutral, severity scoring algorithms we will be using. So basically to score the kind of differences we'll be able to find out. And that we will use two methods in it. I'll go through the slide itself. Am I audible or something just changed? Is it fine? Okay. And then Git integration, and this is something which is in POC, ML enhanced scoring, so we'll go through it as well. Okay, so idempotent backups, we talked about the problem here, and so what we are going to do is okay, so bunch of things are happening on this slide. One is like in terms of normalization examples, this is something which we are removing. So we are removing that timestamp, we are removing the comments as well, which are irrelevant if you want to only target the actual configuration changes. So with our solution, the most important thing is normalizing all that configuration, and based on that logic, we can skip the backup creation if it's just the metadata which is changing here. And that way we are avoiding simply, in our case, we are avoiding having GitHub commit history, all that noise over there. So, okay, vendor neutral design. So we talked about it. Each vendor has a different CLI command, different output formats, or different methods to perform the restore operations. So that is something getting taken care underneath, where based on what the operating system in the inventory, it is capable of triggering specific tasks which ensure that what modules needs to be called. So these are the platforms which are supported, and there is a more of a, I would say, pseudo file over here. So basically you can have same file which will work on all the platforms here. We will explore the actual playbooks in detail moving forward when I'll be showing the demo. Okay, diff severity scoring. So all configuration changes look the same. And if we talk about the problem, we had an example where we said, okay, BGP and change in description is basically getting treated same. So, which might not be, shouldn't be the case every time. It might depend upon your particular use cases as well. So our solution here is to analyze all those configuration differences, use some parsers, identify what resource is getting changed. You can score it based on that, and you can then trigger specific workflows out of it. So here, for example, we said, okay, BGP changes, ACLs are going to be treated critical ones, or will be having higher points in the hierarchy. And at last, we can compare the total amount here, and based on that, we can simply select the severity level or the score in this case. So this is a high level, I would say, flow diagram where we are changing something, then we are getting the diff, we are having parsers, and based on those parsers outcome, we basically generate a score, and that score you can use to trigger a certain workflow. So it could be, okay, if the score is maybe somewhere less than 10, that is like very low level, cosmetic changes are happening. In that case, we can simply go ahead and push the configuration, we can simply merge it or write it. So this one is rule based. I just mentioned it that we have written certain parsers where we are checking like what is getting changed, and based on that we are doing the providing the points to it. But the same thing can be done through some sort of model as well, and that for this example, I have used RFC here, which is random forest. I'm forgetting the complete name, but yeah. So that model we have trained a bit, but the idea is to like anyone can use their own trained model, and they can simply point the solution in that direction. So that should be able to take care of rest of the things. So again, this is the flow here. We are going to get the differences. We are going to normalize the data, and then based on that model, we will do the learnings of like what is the severity here, and then you can trigger your workflows based on that. And this is backup verification part, where let's say if someone have stored backup files and somehow by mistake something changed in those files, right? So we need to have a way to find out whether it is the right file which we should be restoring our configuration to. So in that case, we will be using hashing, where we'll be comparing the hash value every time we'll be performing the restore operation. So the flow for this would be, whenever you'll be creating a backup, it will run the hashing algorithm, it will generate the hash, and then it will add that extra file of like where you will be having that hashing value in the data store, so that later on you can again compare the hash and go ahead with the restore operation. And all of this is like optional, where you can select whether you want to generate the hash or not. SCM integration, we are using an Ansible SCM collection to basically talk to SCM. In this case would be GitHub. You can run the whole workflow with your own like local file system as well. Okay, I think I should simply start with demo. We do have a bunch of those, so let me start it. So this is the file, and what we'll try to do here is try to get connect to a network device, fetch the running configuration, and then push the backup file to some GitHub repository. So this is the task here, where I'm saying that the type of backup is full. So in this case, it won't look for any differences. It will simply go ahead and push the configuration, and then enable hash is false here. It is not going to generate any hash in this case. We're going to have a separate demo for that. And here I'm providing some information like, okay, this is my GitHub username. I'm providing path to my key as well. You can use token. I mean, there are a bunch of options available in Ansible SCM collection. And then we will be simply running it, okay. So we see it is publishing, oh, sorry. Okay, so it simply went ahead. So this is where I created this PR, and let me go back a bit. Let me play. Okay. So this is a pull request which got created as the outcome, and this is the configuration for iOS appliance. If everything is fine, we can simply merge it. Okay, now that we have pushed a configuration, we will be running bunch of like other operations as well, which will have this particular outcome as a base. So let me go back to this folder. Okay, this is step 2. What we are trying to do here is, this time we are saying that the type is diff of this backup operation over here. So that means now it needs to compare the stored backup and whatever the running configuration it will be fetching. It needs to ignore the metadata, and if there is actual config diff, only then it needs to push that or create that PR. So in our case, there shouldn't be any difference because we haven't pushed any configuration yet. So it should be almost same except the metadata difference is there. Okay, so now I should be confirming whether a PR was created on the GitHub or not. So it wasn't, just like it was mentioned on the CLI output as well. Okay, now comes the step 3, and here we will try to change something on the device now, so that there will be actual configuration next time you will be running it. So this is the task I'm using, where I'm saying that this is the interface. It's one where I want to just change the description. For now I'm generating some random number so that demo can work. Like every time it will be generating some random number and ensuring that there is an actual change in the diff in the description. So let me run it. And this is the resource module we are using actually to push the configuration changes. Okay, this is the outcome of that resource module, where it is showing the after state, before state as well, and the commands we ran onto the device. So it is a detailed output. And now we need to run the step 4, which is again, we are running a backup operation with type diff, and we'll try to see whether it is capable of detecting the actual diff here or not. So again, it will fetch the configuration, normalize both the config files, remove the metadata, and then compare rest of the configuration, and based on that it will make a decision whether it needs to create a PR or not. Okay, this is something we can confirm. So this is the PR link URL, and then here we can see that this is the PR which got created with the differences. We changed the description, so that's why it is showing the change in there. Okay, so we are done till step 4. Okay, there is step 5, which is more about restore operation now. So now that we have changed something and we just went through the PR, we have identified, okay, something have changed. Now we need to restore what was the safe state. So that's why we'll be running the restore operation. So we are using network backup.restore operation here. Restore is again part of backup collection. The appliance DR variable here is it is optional by default. In task in the collection is capable of understanding which appliance is there and what default path is there. So here it is checking whether the file copy is possible or not, whether it has sufficient memory or not. So all those checks will be performed underneath. So here we were able to run it, and then we were able to restore to previous description value which was there. So this was the restore operation. And now we can move ahead with our rule-based diff severity scoring. So this is the task for it, where we are saying that, okay, enable severity scoring. We have set it as true, and we will be using a rule-based approach in this one. I have used verbosed output, so okay. Now it says that, okay, I have created a PR, go ahead and merge it, and then we can press enter and continue. So here is the file. We're going to merge it. So now we have a base config in our data store. Okay, now we can continue so that we can change something, and later on it will go ahead and compare the differences and generate some scoring out of it. So it is saying that, okay, change has applied. We change something in the configuration, in the current configuration. So this is a change we just made, and now we can continue here. Okay, so this is the output we are getting, where it says that description changed and even total score, because there was the only difference which was there in the description of interface. So that's why it is saying that, okay, description change, and even the level is low for it, and you can have your own logic of like what action needs to be performed here. So that you can actually manipulate or change based on your need, which will be the outcome of this particular task. And this is the PR it pushed. So that was running rule-based diff severity scoring. Now we'll be using some model to do this instead of rules. And for that we need to provide the model path, and we need to provide the value for enable ML scoring as well. I have also set the hashing to true here as well, so it will generate one extra file in this case. Again, setting a base config. Okay, so this is the file it generated here. And now we have a base config with which we can compare our rest of the operations. So we just applied the same change what we did for rule-based comparison as well. And again, it is very similar to what we did with the previous method. It is able to identify what was the change and then total changes. And then again, severity level is low in this case based on our logic of comparing that total count. Okay, so that is done. We can move ahead with a demo of hash verification. So again, this is something I'm just showing that, okay, it created this PR with the changes. I'm going to merge this one, and I use the same base config in the hashing one as well. So for hashing, we have this verify backup hash that needs to be set to true. So in that case, whenever it will be fetching the backed up file, it will go ahead and generate the hash and then compare those hash values. So what I'm doing here is changing something in the file, so it should be able to identify this change and fail whole restore operation. So here it says that, okay, something backup file integrity check failed, so something needs to be looked into. And last but not least, we talked about being vendor neutral, right? So, okay, let me maximize this one. So this is the task where I'm saying that, okay, I want to target all the hosts which are there in the inventory. So it doesn't know, or it doesn't care about what particular platform we are dealing with. So this is the task where I'm saying that I want to create a full type of backup. Hash file is false here, so it won't generate the hash. And now underneath, it is trying to get connected to each appliance, fetch the configuration, and then generate the files and push those onto the SCM storage here. So in this PR, we should be able to see 3 files because I had 3 devices in my inventory. So one was XR, one was iOS, and one was NXOS. Okay, so if everything is fine, we can go ahead, we can merge it or write it to whatever data store we have. And now coming back to rest of our slides, so that would be some of the key takeaways. What we did through demo was like we ensured that backups are idempotent when it comes to backup type operation with diff. Being vendor neutral, where one playbook worked on all the platforms. Diff severity scoring, we explored like 2 options here. One was where we had parsers written for it, and other one was through a model. Then hash verification. We wanted to ensure that backup operation is integral here, and then Git integration part, and then we explore the ML enhancement option as well, which is kind of in POC, except this one. Rest of the things are something which we are using. So okay, what's next? So these are the resources. If you want, you can explore. Everything is on there on the GitHub. There is this feature branch, and then for SCM integration, the collection we are using, and then there are playbooks as well, which are pretty generic. So if you might be using it and facing any issues, please let me know, or maybe just create an issue against those playbooks as well, so I can help there. So yeah, that's pretty much. Any suggestion, questions, or doubts? Anyone?
I have a question.
Okay.
So, is it possible? You showed obviously GitHub as the SCM for storing like the switch config.
Yeah.
Have you tested, or is it? You mentioned. Is it possible to use like other SCM like GitLab or?
Yes.
Yeah.
We can use GitLab. For sure, that will work. Yeah, and a bunch of other are something which are kind of in as a feature idea which is there. So the plan is to include those as well.
Thank you.
Okay, thanks everyone. Feel free to reach out.